In this lesson, we will be looking at parabolas from an analytical point of view. A parabola is known as a conic section because if you take a cone and slice it with a plane, and the plane is parallel to the side of the cone, you get this shape, which we call the parabola. That point is called the vertex. The definition of the parabola, again from an analytical geometry point of view, is defined to be all the points that are the same distance from a point called a focus and a line called the directrix. So here we have a focus, here we have the directrix, and if you were actually to take a ruler and measure all the points on the curve, which is this red thing, let's take this point, we would measure from here to here and measure from here to here, that's the same distance. If we take this point and again measure from here to here, here to here, the same distance. Looking at this illustration, you can again see we have a focus and we have a line which is called the directrix, and up here I want you to notice that it's measuring the distance between the point P and the focus, and right now it's 1. The point P to the line is 1, and that point P is right here. So as I move that point, it's measuring the distances and saying, look, those distances are the same. And that's how you get that branch of the parabola coming back down. And so all those points would be connected and you would get that parabola. So we have some equations for our parabola, and yes, you need to memorize them. And we have two because we have up and down parabolas and sideways parabolas. So let's just talk about what all these letters mean. First of all, we have an H and a K. H and a K. Notice that H goes with X, K goes with Y, all very alphabetical. Those are our vertex. That's our vertex. Here we have a parabola that has a vertical line of symmetry. And this one we have a horizontal line of symmetry. This one you have an x is squared, that one you have y is squared. Now what is that 4a? That's going to be very important. A, not 4a, but A is the distance from the focus to the vertex and the vertex to the directrix. Since it's symmetric, this is going to be 2a, that's 2a. So from this point to this point, which is called the focal width, how wide is that? 4a. So that determines the width through the focus. Same thing over here. This is A, that's A, and the width through the focus, again called the focal width, that is 4a. So some important things to know. The parabola has a vertex of HK, which is just a particular XY point. It cuts that parabola in half, either through a vertical line of symmetry or through a horizontal line of symmetry. A is the distance from the vertex to the focus. Vertex to the focus is A. And A is also the distance from the vertex to the directrix. Right? Remember that directrix is a line. A vertical line is going to be x equals to some number, and a horizontal line is going to be y equals to some number. And the focal width is the distance of 4a. Knowing those things, your vertex, your A or 4a, will allow us to graph and find equations and all kinds of things for our parabolas. So the first thing we're going to be asked to do is we're going to be asked to find an equation of a parabola and graph that parabola given some information. So I have provided graph paper. It is a lot easier if you use graph paper. So let's first of all plot the vertex for -2. And then we're going to plot the focus. Now just the relationship of those two dots should tell you which way this parabola goes. Does it go up and down, or does it go side to side? It goes side to side. It's going to have that horizontal line for your axis of symmetry. So as you go back and look at your equations and you go, all right, I need to have this formula. Because again, it's side to side, the vertex and focus are located horizontally, you need the y quantity is squared. What else can we fill in? Well, I need h and k. Well, your vertex is h and k. So let's go ahead and put that down. And probably the biggest mistake is not putting h with x and k with y, because we see that 4 first and we just want to write it first. Just be careful about that. So what happens when you have a negative value and you already have a negative there? That's going to become positive. So I have y plus 2 squared equals 4a times x minus 2. So the next thing we need to do is find out 4a. We'll look at those notes. We have from here to here. Well, that distance is 2. Well, is that a? Is that 4a? Is that neither? A is the distance from the vertex to the focus. I have vertex to the focus, so that is a. And so 4 times a would be 8. So that's your equation. The next thing is how do I graph it? Well, I need some more points. So if a is 2 and 4a is 8, remember that's your focal width. That's how wide the parabola is through the focus, and we have a line of symmetry. It's symmetric. So I'm going to go over 1, 2, 3, 4, which is half of 8. 1, 2, 3, 4, half of 8. That is my equation. What is that directrix? Well, it's going to be a vertical line parallel to the y-axis, right? And that distance is 2 from the vertex to the directrix is 2, and we're going to have a vertical line there. What is that equation for the directrix? Well, a vertical line is always x equals, don't just tell me a number, it's not just a point, it is a vertical line, and that answer, let's see, x is 2. Right, so I have the equation, I have a graph, and I also have the directrix. In this example, they're giving me the directrix and the focus, and again asking for the same thing. So let's graph what we have. The directrix y is equal to 2, and the focus negative 4, 4. So just looking at that, which way is that parabola going to be? Is it going to go up or down or side to side? Well, it always helps me remember to say it hugs its focus. If you have a focus, if you're focused on something, give it a hug, all right? So we're going to hug around the focus, which means that this parabola should go something like that. But I need a little bit more exact. But knowing that, I know it's vertical, so I'm going to use this equation. And let's see what our numbers are. So I need to find the vertex. Well, the vertex is located in the middle or directly between the directrix and the focus. So it should be that point right there. What is that point? I believe h and k is 4, 1, 2, 3, oop, that's negative 4, and I went up 3. And that's why graph paper is so nice, you can actually count the squares. Okay, so that's my vertex. Now I need to know what A is. Again, A is the distance between your vertex and your focus. So A is 1. So 4A is 4. So here's my equation. X minus a minus 4 equals 4A times y minus 3. The next thing I need to do is graph it. That's my focal width. Again, through your focus, it's 4 wide. Since it's symmetric, chop it in half, so I'm going to go side to side 2. Here's your vertex. And then just play connect the dots. Okay, this one's a little bit different. They're giving us a vertex and a point, and it tells us it has a vertical axis of symmetry. All right, so we have a vertex, and we have a point, and I know, all right, the axis of symmetry goes through the vertex, so I know I have a vertical axis of symmetry. Well, that definitely means that my x quantity is squared. But what else is it going to do? It's going to have to go down, right? When it goes down, this quantity is going to be negative, and when it goes left, 4a is going to go negative. Let's fill in what we have. So our vertex, our h and k, they tell us that. We don't know where the focus is. You cannot assume that focus is there. So just get that out of your mind. It may be there, but that is not what's given. Okay. So we have here is h and k, which is 1, 2. And this is just a general point, x and y, which is 2, 1. We can fill x and y in with 2 and 1, h and k in, and we can solve for a. So let's do that. So x is 2 minus h is 1. And I'm just going to say 4a. I know it's going to end up being negative though. Y is 1 minus k is 2. And sure enough, 4a is negative 1. So if I want to write my equation, oops, not 2, but 1. 4a is negative 1. So that's my equation. Graphing it, just using symmetry, I know if there's a point over here, there's a point over here. That looks good. But what if I ask you where the focus is? All right, where is that focus? So if I erase this, well, if this is the focal width, then A must be negative 1/4. So from your vertex, if I went down 1/4, that's my focus, and if I went up 1/4, that would be my directrix. So my focus would still go over 1 and not up 2. I would have, I'm here at 2, and I had to go down 1/4. So what is that? 1 3/4. And then my directrix, that's going to be a horizontal line, 2 plus 1/4. So that focus was right there, very, very close to that vertex.